Good evening, ladies and gentlemen. Welcome to the second lecture, Process Safety Management. And today, under Process Safety Management, we will be dealing with risk management. You know, we have been discussing about the pillars under Process Safety Management, the principles under Process Safety Management. And today, risk management is what we will discuss. So first, let's start with risk management. Risk can be managed in many ways. We can manage risk in many ways. Generally, the sooner in the process life cycle you implement a risk management decision, the cheaper it becomes. So the most cost-effective time to implement safety feature is during the design process. So when you want to put risk management practice in place in a procedure or in a process, the best option is to make it at the beginning when you are designing the process. Like, for example, you want to manufacture a car, and you are planning that it is when the car starts functioning that you will now put safety device that will not. No, it is at the beginning of the design of the car that you put all necessary safety design in it. Where would the brake be? How heavy the car will be? What is the speed of the car? How many fuel can the car have? What is the size of the tank? All those things that you are designing are what we call safety in it. Because you say if the car is small and is carrying large fuel, if it has accident, the fuel will easily consume the car. So you have put the risk in place. If the car is heavy and the brake is small, what happens? The brake will not be able to catch up with the weight of the car. So the ability to put risk at the beginning of design is the most important things you do. Inherent safety design is another way you can put the thing on. Inherent safety design. Inherent safety design is another way you can put things in place. Inherent safety design is another way you can So inherent safety design, when you use of inherent safety design principle to avoid hazard rather than controlling them with added non-protective equipment. So when you make your design very simple, you put design inside as part of the control for risk, for hazard, is something that is very, very, number one, it reduces inventorization of hazardous materials on site. It's used less aggressive operating procedure. Use of necessary operational remove issues by design, not by adding consequential procedure operation. So other strategy employed under inherent safety design is minimize transportation and storage of hazardous materials if possible. If you want to transfer hazardous material from one place to the other, you must look at the procedure you want to use to move it. This is very, very key. Let me give you an example of how to manage risk. They said, once upon a time, a king offered 3 young men an opportunity to take a chance for true love. They could open 2 doors. One of the door has a dragon, and one of the door has a true love. And it gives them the opportunity that they should open only one door at once. They can't open the 2 doors at the same time. So the first man decided not to take any risk. He said, no, I don't want to. If I go and open the door that has dragon, the dragon will eat me and I will die. So the guy left and he never found love. The second man hired some risks professional. They collected data on tiger and true love, on everything. They did this thing. They used machine to detect the sound of dragon and calculate the probability. By the time they finish what happened? Regardless of, he opened the recommended door and got eaten by a low probability dragon. The third man took a course on dragon slaying. The third man took a course on dragon slaying. Yes, they said it is dragon that is there. If I know how to kill a dragon, even if the dragon attack me, I'll kill it. That is the purpose of inherent safety design. You have incorporated in yourself things you want to do in case there's an hazard in it. Yes, there's a dragon in it, but he went to train himself on the method and the methodology of killing a dragon. So if I face a dragon, yes, I will kill it and it will die. And that's how he is able to save the day. Another thing we will do in standard in process safety management is operating procedure. The operating procedure is also a key aspect. Operating procedure is also a key aspect in process safety management. These elements focus on documenting written procedure, maintaining them, and constantly using them to maintain facility integrity. If you don't have an operating procedure, you will not have a good system in place. Every organization must have what you call a standard operating procedure. Every organization must have a standard operating procedure. And it must be written. It must be written, it must be maintained, and you must constantly use them to maintain facility integrity. Not even in factory now. A lot of organizations now put operating procedure for different things. If somebody, during this COVID-19 now, if somebody wants to come into your office, you have an operating procedure. You must first wash your hand, use sanitizer, or some people now have disinfecting chamber. You pass through the disinfecting chamber, you cover, you use your nose mask. If you don't use your nose mask, you can't come into our facility. Why? Because they don't want the person coming in to come and what? Infect the workers or infect other persons. So they put what? They put a standard operating procedure in place. So what are the goals of an operating procedure? It must be current, must be accurate, and it must be useful. If a bank says, okay, now I will only be using metal detector to check my customer, either they like it or not, let them come in without nose mask. What are they happening? They are not current. They are not current. They are risking the life of their workers because they don't know whoever is coming to the bank. They don't know the COVID-19 status of the person. So the goal is that it must be current, it must be accurate, and it must be useful. What types are covered? It can be normal operation, it can be infrequent operation, it can be special high hazard procedure. An operating procedure must be, sometimes can be specially high hazard procedure. You can't just say because you know how to fly an helicopter now. Somebody who has a license in helicopter said he wants to go and fly a Boeing 737. No, it's a specialized high hazard procedure. You can't use the experience of an helicopter and say that is what you want to use to go and fly a Boeing 737. No, it is not done. You must be specially trained for it. So a standard operating procedure can be narrative. The ways to write a procedure, you can be narrative, it can be, they can write it down, written in long paragraph, difficult to follow, most common, but see, it must not be difficult to follow. Most common, it must be simple narrative. The paragraph similar to narrative, but give some structural through numbering. Some are in form of paragraphs. They can be in form of paragraphs, and it must not have too lengthy words. Some can be outline, short sentence with number or identification structure for group information. Some procedure can be multi-compartment of information, usually used for troubleshooting or guide. Some procedure can be like that. Some procedure can also be flow charts. Some can be flow charts, flow diagram. From steam A to steam B, from steam B to steam C to steam D, then go back to steam A before you come back to steam F. Some people say, but from D you should go to E now. But no, there's a reason why they said it must go back to what? To A before it goes to E. So you must follow a flow chart. So some procedures are not written down. They are in form of a flow chart. Some are in form of what? A checklist. Some are in form of what? A checklist. Some are in form of a checklist or a play script. Some can also be in form of a checklist. After this, check this. Wait for 5 minutes before you put on the machine. You must make sure that it is 5 minutes. Some people will not make sure it's 5 minutes. Those time lapse can cause an accident, and it can. So basic action with sports, initial or check of action are very, very important. Also, some procedure can be in form of play script for multiple operational that need to perform tasks together. When too many people are performing, like inside an airport now, if you want to put an operational procedure for an airport, it can't be a one-way. It can't be a one-way because there are many tasks that are happening at the same time. Somebody is checking the luggage, somebody is checking the passport, somebody is checking the scanner. So the operational procedure for an airport will be in form of a play script where too many people are acting at the same time. Sometimes an operational procedure can also be a 2-bar, 2 column, one with step, the other with initial details. So you can put it in step 1 at this side where you just put the action, where the second side will be where the procedure will entail. So what should we expect in a procedure? For each step in a procedure, the following should be outlined in a written protocol. Any expected system response, indicator that the step was performed. If check the battery, let's say you want to start a vehicle, check the battery, check the water in the radiator, check the headlight, then start the car. Some new cars now, if you put it in drive, the car will not work. The car will not start. If you put the car in drive, the car will not start because a mechanism has been put in place because they don't know that if you put it in drive and you mistakenly start it, what happens? It can speed off and injure people. So a mechanism has been put in place that if your gear is in drive, the car will not what? Will not start. That is an indicator that your car is in what? Is in drive. It does not follow the standard procedure. Always put the car in parking before you what? You start. So safe operating limit. What is the operating limit of that device? A procedure will also, some procedure will put it. You can't speed more than this. You can't go more than this. The boiler cannot go more than 100 degrees centigrade. All these things are put in the procedure for safety. Consequence of deviating from the limit. If you deviate from the limit, if you if you speed more than 120,
admin.
If you speed,
must be third one must be initial cap. Must be initial cap.
If you speed,
third
if you speed more than some limit in some cars now, the car will start blinking. The car will start blinking. That'll be pom, 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 pom. It shows you that you are speeding more than what necessary. Some cars now has been put, some GPS has been put to some car by the side. Some signal will be put by the side of the car, by the both right and left. So if you are driving and you are moving towards the covert, there'll be a signal that you want to hit a covert. So there are safe operational limits that are also put in procedure. And when you deviate from the limit, there'll be a procedure to guide you that you're already going out of the limit. Those are the things you must put in in our operation procedure, so that we will know whether we are doing the right thing or we are not doing the right thing. Adroit procedure should be followed if deviation from the limit is detected. So if there's a deviation from the limit, what should we do? Like if a customer mistakenly carry a gun into a bank, if a customer mistakenly carry a gun into the bank, the police officer there, the people there should not immediately, because they see a gun in his hand, they should not shoot him. Don't shoot him because he mistakenly carried a gun in a bank. He may not be a thief. He may be a military officer, he may be a police, he may be somebody that has power to carry a licensed gun. But he forgets that he's coming into what? Into a bank. So don't say because you see him with a gun, the next thing is, hey, Oga, go down. You start shooting. No. There must be a procedure to follow if there's a deviation. There's a deviation that, okay, people should not carry gun into a bank. So if somebody carry a gun into the bank, what should we do? You ask the person to move aside, identify himself, then ask him to what? Surrender his gun. So when he's now going, he cannot be, you will not give him his gun back after checking his what? His identity. Don't say because you see his gun with him, you see a gun with him, he's already. So if there is a deviation from the procedure, what should we do? Those things should also be in our standard operating procedure. Our standard operating procedure should not be just circumstance. Somebody carried a gun into the bank. Immediately carry a gun to the bank, arrest him. No. There must be, if there is a deviation, what should we do? Validation and maintenance. Also, a standard operation procedure must have a well-written operational procedure that must contain about how you validate and how you maintain an equipment. How you maintain an equipment, how you maintain a process, how you maintain a business. The last example I gave now, you won't say because you are a security guard in a bank and a senior officer, probably a major general, comes into the bank, and because you are able to be vigilant, you saw his gun under his clothes, despite he's wearing mufti. You saw his gun under his clothes, and you say, "Hey, Oga, stop there! This! Why?" You start shouting on him. No, there must be a validation process. There must be a validation process. However, the correct and safe practice should be the one finally reflected. Don't put every process in place. Make sure that the process you want to put in place is the process that actually works and it is practical. It actually works and it is what? Practicable. Procedure must be available to those using them and those you may need to use them infrequently. Don't write a procedure and go and put it in one place, and the workers don't have access to it. Sometimes you have visitors who come to your office. Let's give example. If people come to your office and there's a gas leakage in your facility, and you have an operational procedure that says if a gas leakage occurs, these are things that must be followed. But that day you have excursion where students come for excursion, a lot of people come for excursion. You can't be explaining to all of them. You quickly make the the operational procedure available for them, so that they read it. Don't answer phone, no. Don't press your phone. Don't do this. If you press your phone, it can trigger an alarm. It can cause an accident. All those things are things you must what? Put in place. They should be updated and reviewed regularly. All operational procedure must be updated and reviewed regularly. As a company grow, as a company diverse, we must update our operational procedure, and we must review it constantly. We must review it constantly. The world is going global now. Most things are being done digitally. So if you put it that every worker must sign in before they come into work, it will delay a lot of time. If people are to resume by 8 o'clock, that means you expect people to come by 7 o'clock and start work and signing in before they come in. But if there is a login tag that is a scanner, what happens? People just wipe it and they go inside, and the computer takes their record. That means you have moved into the new system. You have been able to upgrade and review your system in line with what? In line with all procedure must be controlled to ensure that only the correct practice are being used.
Hello, sir.
Hello?
Hello?
Hello, yes?
Look, now who's on the line, baby?
Sorry, somebody is disturbing us. Can you mute yourself, please? Can you mute yourself, please? The person calling.
Who?
So
it's you now.
Another process safety management tips is safe work practice. Safe work practice. This element focus on using safe work procedure during maintenance or routine work. You must put in a safe work practice in place. So, for example, non-routine work, this does not refer to the frequency of task or the tech deck. Any work that is not part of the normal operating procedure, there must be what you call periodic inspection. There must be periodic inspection. There must be periodic calibration. There must be periodic repair. There must be periodic testing, and there must be what? Maintenance. These are not things you do every day, but they are non-routine work that you carried out. You must continuously do inspection. You must continuously check the calibration, and you must continuously do the repairs. And you must continuously do the testing and check the maintenance. That's why this aspect of process safety, how do you do your process in a safe way? One of the key principles is safe work practice. And how do you do a safe work practice? By doing non-routine work. They are not things you do every day, but they are things that are very, very important. Inspection is very, very important. Calibration is also important. Repairs are also important. You don't do repairs on machine all the time, but you must do repair on it. There are some boats that will have loosened out. And the vibration of the machine will be very hard. But so they need to retight it properly. There are some things that you need to test. If you are on a production line, you see that people from the laboratory will come and carry some of the product and test it. They are testing it continuously to check whether the quality of the product is still intact. They want to check whether the quality of the product is still intact, because during the mixing period, there's probability that the team may not mix properly. So they want to do what? They want to test it. So that's another way. So what you do is you cover all bases. You cover all bases. Under the process safety management, 3 sets of procedure will cover all possibility to reduce risk. Element 8 is operating procedure. Element 9 is safe work practice. Element 10 is maintenance procedure. If you have these 3 key process in place, there's probability that your system is in a safe procedure, and you'll be able to reduce risk. Venphone. Who is Venphone V? You raise up your hand. Any issue? Somebody did not name his phone Venphone. You are raising up your hand. Do you have any question? Venphone V. You are raising up your hand. Any question? I continue. Another key aspect by which process safety can be maintained, the integrity and risk of a process safety can be maintained, is work permit. Make sure that you put a work permit process in place. A non-routine work should use a permit system which must be authorized and confirmed by the correct personnel prior to the activity being undertaken. There are some works that need permit. There are some work that needs permit. There are some works that need special scrutiny. Imagine somebody that wants to work inside a boiler, or somebody that wants to work in a big control section, and he is drunk. The person is drunk. Can he control his ability? No. Or somebody wants to work, is a forklift operator. He's a forklift operator and is drunk. So the supervisor will require a what? A work permit. There are some work that will require a special work permit before you can do it. A person that is always agitated, a person that is always getting quarrel all the time. If you have security personnel in your company, and your company decided to obtain firearm license, and you are going to give your workers firearm license for them to carry gun, and you find out that the most resourceful of your officer is the one that gets angry easily. Will you give that kind of a person a gun? You will not give him a gun. So there are some works that need special permit to be done. And permits are updated at each shift. Don't say because I gave permit to Mr. Ade last week and he's coming to do this work again this week, I won't give him permit. He has permit last week. No, you don't know the condition is coming in this week. So you need to do the checking again to confirm that is what is in a safe position to do the work. Permit also ensure that appropriate lock on valves or switch are in place prior to work taking place. You want to work, but the work you want to do are places that has tagged out and log out. So you logged it out and you plug it and you just sit down in your office and you ask your worker to go and work. When they come back, they say, "Oh, God, the place is locked." Yes, I know the place is locked. You now give them the lock and the what? The key. Because you have tagged it out and you have logged it out. And you gave somebody a permit to go and work on it. So if anything happened, you know it is Mr. Hay that I gave the permit to work on that system. That is one thing a permit will help you to do. A permit can also help you to check a logout and a tag out. So where do we need permit for? Where do we need permit for? Permit will require the safe work procedure are used in these following places. A confined space, somebody that wants to go and walk under the ground, or somebody enter a tunnel. You know, people welding the underground tunnel, they want to work, you need a permit to ensure that that person is in good condition before you go under to go and do that thing. Welding, when somebody wants to do a welding job, or somebody is cutting with a no fuel resource, or is working in a flammable place, he needs a permit. You want to be sure that that person can handle that kind of job. Opening a vessels or opening a line, you also need a work permit. Logout, I'll give you an example. Electrical work that require to be safety, serious safety consideration have to be in place. You need a permit. The permit will let you know that this is the person that was authorized to do the work. So if there is any mistake with respect to the work, the person will be queried, or the person you know who have the custody of the work. Construction, if you are working adjacent or operating in a construction site, you need permit also. You need permit also. So it is very, very important to have it at the back of our mind that some work permits are also very, very important. Let's give an example. The explosion at Pierre Alpha was caused by improper managed safe work practice. For example, the safety valve inspection and testing. An offshore rig exploded, resulting in 167 deaths and 1.7 billion naira in damage. The explosion was caused by a hydrocarbon leak due to the removal of a safety valve on a pump, which was removed for inspection and testing, and not restored prior to the shift change. The pump has been taken out of service earlier that day for maintenance work. The night crew was unaware of the maintenance work and had to authorize electrician to resupply the pump with power in order to return it to service. It is unclear if the night crew knew of the maintenance was incomplete. You see what happened? An oil rig exploded, killing 167 people and 1.7 billion in damage. What happened? The explosion was caused by an hydrocarbon leak due to removal of a safety valve on a pump. You see, the pump was taken out for maintenance, but the safety valve of the pump was what? Was removed. And there was no record in place that the safety valve had been what? Had been removed. The night crew just take the pump and went to what? Install it, not knowing that the safety valve had been what? Had been removed. And when they were working, the hydrocarbon leak and it causes the what? Explosion. Process integrity and reliability. Reliability. This element focus on the design, installation, and maintenance of equipment from when it is fabricated to its retirement for unsure if it is fit for use. You must check the integrity on the how reliable an equipment is before you use it. You must check an integrity and how reliable an equipment is before you use it. Sorry. So critical elements include very important message. Maintaining of the process integrity is key. Equipment failure has been a leading cause of accidents in the process industry due to what? Poor design, poor installation, and what? Poor maintenance. So to maintain integrity, inspection, testing, and what? Certification is very, very important. To maintain integrity of an equipment, you must carry out inspection, you must carry out testing, And you must also carry out what? Certification. Let's look at another example. American Airlines Flight 191 in 1979. That is the deadliest air crash in the United States, killing 273 people. What caused the crash? The cause by improper maintenance procedure. They did not follow proper maintenance procedure. In attempt to save time and money, the airline instructed maintenance mechanic to remove the engine and the pylon together instead of doing it separately. The procedure is that you must remove the engine and the pylon at different times. Don't remove them together. But because they want to save time, they remove the two at the same time. By removing the two, this results in the damage of the pylon, and which was not detected when they were removing it. They fixed it back, and during takeoff, the pylon failed and the wing of the plane ripped off, causing the crash and killing people. That's where we'll stop today. Today, we'll take on different aspects of process safety management, and we look at risk management. And we say risk can be managed in many ways. Generally, the sooner in the process, the earlier in the process cycle you manage risk, the better. Don't design your equipment. After designing it, you now say you want to manage risk. No. Incorporate risk management at the early stage of designing. And while you do that, you do what you call inherent safety design. You put safety design as inherent safety design procedure in it so that it will help you to reduce risk. Also, another element is operating procedure. Every organization must have an operating procedure that must be written, it must be maintained, and it must be constantly changed or maintained. We also talk about safe work practice. Safe work practice. How do you work safely? What are the non-routine work procedures that you must put in place to maintain safe work practice? This includes inspection, calibration, repair, testing, and maintenance activity. And I made mention that there are some work that you want to do that permit must be what? Issued. Permit must be issued before people carried work in a confined space. If you are carrying an hot work, if you are welding or you are working in a flammable place, you need a permit. If you are working in an open vessel or you are working in a vessel line, a work that requires log out and tag out, also some construction works you need permit to carry them. And I gave example of improper manage of work practice, where an oil rig safety valve was removed by a workers in the morning, and they did not document it properly. And the workers that came to work at the night shift just carried the machine and using it without knowing that the safety valve has been removed. That caused an explosion and it killed over 167 workers. Asset integrity and reliability, how reliable the thing is also one of the key things. And last, I gave example of how to manage an integrity of an equipment. How do you manage an integrity of an equipment? How do you check the integrity? By doing inspection, by doing testing and doing calibration. When an airplane has flown for a particular hours, they will take them for recalibration. They said they are taking the plane for recalibration. They want to go and check some of those things. And I gave example of American Airlines Flight 191 that caused a fatality of 273 due to what? Improper maintenance procedure. The standard maintenance procedure is that the engine and the pylon must be removed at different time. But because they want to save time, what happened? They remove the two at the same time, causing the damage of the pylon. And when they fix it back, it caused a clash and killing people. Thank you, ladies and gentlemen. We'll continue the rest lecture from the other slide as from next week. Any question? Any question? Today we have a lot of attendance. 7 people are online today. That's very good. That's very encouraging. Mr. Ilesomi, hope you don't have problem with your network now. Mr. Gujobi? Okay, it's not there. Thank you, ladies and gentlemen. After the class, after finishing with the MSc students, I will upload it on YouTube and send the link to you.
Okay, sir.
So you can listen to the lecture all over again if you want to.
I don't have any.
Okay. Thank you very much. Thank you, everybody.
God bless you, sir.
Bye. Enjoy the rest of the week.
Okay, sir.
Thank you.